All right, let's do a recap. Last lesson, I said in order to sketch this 14FHI, you really don't have to do all three exercises. You just got to get a sense of what you need to do, yeah? One, you need to know the shapes. So sine graph and a cosine graph. Recapping, sine graphs look something like this. Cosine graphs look something like this. All right? But remember the difference between them. Sine starts at the middle. Cos starts at the maximum. Okay, that's the difference. So one starts at the middle, one starts at the max. So I'm going to write here middle, max. Again, you don't need to memorize it. You can look at a unit circle and you can probably tell. See, in a unit circle, sine starts at 0. So sine is the y value. So you can see that when you're here, y value is 0. But when you're also here, the x value is its maximum. The x value is a 1 value. And y 0. Okay, so that's the difference between the two. Y 0 here and x is 1 right at the beginning. That's why at 0 degrees, it starts there. Then when you go rotate 90 degrees, y value is at its maximum, which is why it reaches the maximum of 1 after 90 degrees, but then x values become 0. That's why it reaches 0 on the midline, and that's how you can predict the graph. Okay, so it's just based on a unit circle. So now you know the shapes, let's recap. Let's say I want you to sketch this graph, because you're only doing vertical translations at year 11. Your horizontal, you will learn in year 12, just because of timing, and it's too complicated. It takes too long for you guys to learn for the first time. Let's recap. Amplitude. Which one tells you the amplitude again? Can I please have Artie? Which one's amplitude? 2. The number in front of the function will tell you the amplitude. Remember, even if it's a negative, it's still 2. Because amplitude describes from the center to the maximum, or from the center to the minimum, what is the distance. So it doesn't matter about the sign. The sign just changes the shape, right? It doesn't actually change the amplitude. So amplitude is 2. Very good. What's the period again? There was a formula for the period. Remind me what that was. Let's go Lucky. What's the period? How do you find the period again?
It's going to be 2 pi over 1.
Very good. So it's 2 pi on n, and n is the number in front of x, and Lucky, you've picked it out correctly, n is currently 1. That's why it's 2 pi over 1, but 2 pi divided by 1 is actually the same thing as 2 pi. What is the period? Period just tells you how long does it take to make one full cycle. Okay, so this is one repetition. You can do another one, and you do another one. So each oscillation is called a period. So it takes 2 pi to make one. So at the moment, don't draw this bit. At the moment, I'm visualizing this. I've got a sine graph, so it's meant to look like this. I have amplitude of 2, 2 minus 2, and I've got a period of 2 pi. So it must mean all the way here is 2 pi, and that means that must be pi. Right? So this is what I'm visualizing at the moment. Don't draw it. What's plus 1 do? That's what we're practicing today, or pretty much the exercise. Plus 1 tells us up 1. So if you have to visualize this, you're literally just grabbing the graph and you're shifting it up by 1. So the graph should look, whoops. Oh my God. Here we go. Where is it again? Over here. So the graph should only just shift up by 1, and that only changes your amplitude, so the max and minimum. So before it was negative 2 and 2, we now know it's gone up to 3 and negative 1. That's the idea. Okay, so don't sketch that. I was just showing you so that you have a visual idea of what's happening. Okay, so don't sketch that. So we know now the graph will look something, okay? So something, if you just had to think about it, the graph has gone up by 1. Minimum now is negative 1 and the maximum is 3, roughly. Okay, so this is your new midline. That's your new middle because everything has shifted up by 1. Okay? That's what this describes. But you have a domain. It's not from 0 to 2 pi anymore because remember you said 0 to 2 pi. It's from negative pi to pi. So that means where it used to be here, which was at pi, it's now there's a pi over here, negative pi to pi. So if you had to visualize it, the graph clearly will likely do something like this. That bottom bit. Oh, that's a terrible graph. Let me do it again. Like that. Yeah. And it's meant to continue. Okay, so you can continue and oscillate. So my graph here, instead of it actually continuing on from this bit, it actually stops right there. That's what the domain is implying. So if I asked you now, just looking at that, how many x-intercepts do you roughly expect? How many x-intercepts can you possibly get just visualizing that roughly? 2. Okay, and that helps you if you can visualize it. If you can't visualize it, it's okay. You can do all the calculations and you still be able to get it. But that's what I always expect students to get to. When you're reading the equation, this is what I want you to see in your head. Don't draw it out. I just do it so that you can visualize what's going in my head. So I look at that and I'm like, oh yeah, there should be about 2. There is one y-intercept that I can see there, so let's calculate them. Then that's when you sketch it, it makes it much easier to do, right? So here we go. Y-intercepts. We know that to find the y-intercept, you let x equal to 0. So here's my x. You're going to let x equal to 0. Let's solve it. The equation was y, so 0 equals 2 times sine of x plus 1. Oh, sorry, x is 0. What am I doing? It's over here. Do your exact values. Let's calculate it. Y is equal to 2 times sine of 0 plus 1. But sine of 0 is equal to what? Can I please have Namafi? 0. Very good. That's your exact values that you have to remember. So sine of 0 is 0. And 2 times 0 is just 0. So your y-intercept must be 1. Which hopefully that wasn't a surprise to you, because we shifted the graph up by 1. So initially it was at 0, went up by 1, so of course it's at 0, 1. So even if you didn't know that, solving for it should have proven the fact that your intercept here should have been 0, 1. So that's good. We're on the right track. Next one, x-intercept. We expect that you should have 2. So let's see. Let's see if it's true. So x-intercept, you have to let y equal to 0. Let's solve it. 0 is equal to 2 times sine of x plus 1. Let's do it. How do you solve this? You try to find x, got to remove everything else. What's the first thing you're going to remove? Let's go with Anthony. Minus 1. Minus 1 on both sides. You now get negative 1 is equal to 2 sine of x. What's the next step, Mate? Divide both sides by 2. So here we go, divide 2 on the right, divide 2 on the left. 2 cancels out. And you get negative half is equal to sine of x. Now that's very similar to what you've been doing in exercise, I think it was 14D, or no, G? Yeah, 14G, where you're solving. And if you can do G, you don't have to do D and E. D and E symmetry properties and exact values, right? So here, you're trying to find x, so to remove the sine, you have to do sine inverse on both sides. So I'm going to do sine inverse on the right, sine inverse on the left. These two cancel out, and you essentially get x equals to the sine inverse of half. Negative half, thank you. I'm just going to rub this bit off, so because we didn't need the graph, it was just to help you visualize what I'm thinking. All right, so from this step, this is where we have to use the unit circle. When you say sine inverse of negative half, you're just asking, when will sine be negative? Sine represents which one again? X, Y, or gradient? Y. So you're asking on this unit circle, when will you have y values, which is the vertical axes, which quadrants will ensure that y values will be negative? Which quadrants? 3 and 4. So we know that's here, 3 and 4. So 3 and 4. Quadrant 3, quadrant 4. So you don't need to remember the ASTC. You're just looking at the coordinates. 3 and 4 is when sine is going to be negative. Now you need to know what the base angle is. Sine inverse of negative half. So forget about the negative because we now know it's quadrant 3 and 4. We just need to know sine of what angle will give you half. What's my reference angle? Sine of, let's test your exact values. Let's go with Milena. Do you remember? 30 degrees. So it's your index finger. And the radians for 30 degrees, what is that, Zoe? Pi and 6. Very good. So 30 degrees, that's pi and 6 distance on the outside. Okay, but since pi x is representing radians, you have to work in radians. So here we go. We went from negative pi to pi. So let's practice it. Starting from negative pi, which is over here, because remember, clockwise is negative. And then you're going all the way from negative pi all the way to pi. Because that's negative pi to here 0, and then 0 to the next one is pi. Okay, so you've done one revolution. It's one revolution there. So you went from here to here 0, and then from here to here is pi. So now you just write out your possible answers. Starting from negative pi, which is here, that's where I started, based on my domain. I had to go towards 0, but as I go there, I get to my first solution by negative pi plus pi and 6. So every time you go clockwise, it's adding. Yeah? Every time you go clockwise, it's adding. Every time you go anti-clockwise, it's subtracting. So your first solution, negative pi plus pi and 6. That gives you one answer. The second answer is, so I've got my first answer. Second one is, as I rotate closer to 0, I get my second one. So that must mean I'm short of 0 by pi and 6. So we're going anti-clockwise. Anyway, so the next one is 0 minus pi and 6. What does this work out to be? That gives you, let's work on fractions. Let's see how good your fractions are. Who would I chosen? Let's go with Christina. What's negative pi plus pi and 6? Very good. Negative 5 pi on 6. For those who don't know how to do the fractions quickly, here's a trick. 6 times that pi, so 6 times negative pi is negative 6. And then negative 6 plus pi is negative 5 pi. And that's a quicker way. So 6 times 0, 0, 0 take away pi, it's just negative pi. So negative pi and 6. Okay, if that helps for those who struggle with fractions. So these are my two possible x-intercepts. But the one thing I want to keep teaching you is how do you calculate for all possible intercepts? Because what if you predicted wrong? What if you thought it was 2, but it was actually 4 or 6 or 8? So you have to kind of guess it, right? So how do you guess it? Here's your interval. X was between negative pi and pi. You found 2 of the possible answers. You got negative 5 pi and 6, and you've got negative pi and 6. So these ones are clearly within the domain. To work out if you have any more within the domain, you simply, if you go to the right, you add by the period. If you go to the left, you subtract the period. Now what's the period again? It was 2 pi. This was your period right here. But since this is out of 6, let's write that period out of 6 so that's easy to add and subtract fractions. So write 2 pi out of 6. This is currently out of 1. So if you want to write it out of 6 times the bottom by 6 times the top by 6, that's the same thing as writing 12 pi over 6. 12 pi over 6 is the same thing as 2 pi. So when I say add the period and subtract the period, what am I talking about? See, this is your solution. That was from one revolution. What I'm doing is I'm saying, what if I add another revolution? Because one revolution is one period. If I do another revolution, I get my third possible answer. For this one, if I add another revolution, I get another possible answer. So you get another 2. What you're not sure is if that another 2 still fits in the domain or not. That's why we do that. It's just a quicker way of trying to find how many solutions there are. Now I know it's only 2, but for later questions, later on when you can't tell when there's a dilation, that's what we do. We just add and subtract the period up until it passes the current domain. So here, let's test it. Adding on, now the period is technically 12 pi on 6, so if you add 12 pi on 6 to this one, and you add 12 pi on 6 to this one, it's really just like saying negative pi plus 12 or negative pi plus 12. Negative pi plus 12, what's negative pi plus 12? What does that give you? Negative pi plus 12. Negative 7. So I either have negative 7 pi on 6 versus this one plus this one, so negative pi plus 12 gives you negative 11 pi out of 6. Is that within the domain or out of the domain? Out, because this is more than pi. Pi is 6 out of 6. But that's negative 7 out of 6 already. So this is negative pi, so negative 6 out of 6. That's already too low. So I cross this off. Can't be. Can't be negative 11 on 6 because that's even worse. That's even further in this direction. So this can't fit. Then we say, all right, well, let's do the other way then. Let's say I subtract. What if I said subtract 12 pi on 6 and for this value, and I subtract this value by 12 pi on 6. See what you get. Same thing, negative 5 take away 12 gets you now negative 17. Still worse. And then negative pi take away 12 again, negative 13 pi on 6. Still worse. So hence, there's only 2. These were the only 2 solutions that fit in the domain because you did 1 revolution extra and 1 revolution backwards, and both of them are 2 out of the domain, so it can't be. But when you do the ones with the dilations, you'll find that an extra 2. Usually there's an extra 2 or an extra 4. Okay, so that's one of the quicker ways to solve it. I sometimes do it this way, sometimes I don't. The more complicated ones, that's how I do it. Okay, add and subtract the period. Okay, so I'm just doing revolutions forward, revolutions backwards to see how many times I get the solutions within the domain. Let's do another one. That was probably as hard as it gets. So once you've got all of those answers there, you can see why the students, when they do horizontal and vertical and dilation, it takes 25 to 30 minutes to do, because solving the x-intercepts is one of the hard ones, and then putting it all together into the graph. So on your graph, you wanted from negative pi to pi. You found the y-intercept, which was 0, 1. You found the x-intercept so far, which was negative 5 pi and negative pi on 6, so negative pi on 6, negative 5 pi on 6. You know the minimum is negative 1, and you know the maximum is 3. And you know it's a sine graph. So, this is roughly what the graph looks like. Because the period is 2 pi, so that's 1 half already. You're missing the endpoints. Endpoints. Okay, so endpoints, how do you work it out? Sub pi in and figure out the y value, sub negative pi in, figure out the y value. But we already know, just logically from before, you just shifted the graph up by 1. So it should be 1. But if you weren't sure, if you didn't know it, you can sub in the coordinates. Find sub x equals to pi, and you should be able to get 1 as well. Okay? But that's what I mean. So there's a bit of logic as you're doing them. But why does this become hard? Because there are 3 things you got to solve. 1, y-intercept. 2, endpoints. Especially when I move it left, right, up, and down. But in your case, you're only moving up, so it's easier. But for those that are moving left and right, finding endpoints is not easy as well. And then 3, x-intercept. One of the tricky parts is that sometimes when the graph, why the year 12s can take 25 minutes to sketch when you put all of them together is because even after you know endpoints, x-intercept, y-intercept, you may not know roughly which part of the graph gets cut off. So that's why it's a bit trickier. I normally teach my students to find quarter periods. So from this point to this point. So midline to max, max to mid, mid to bottom, and bottom up. And there's a pattern. Once they know the pattern, you can sketch all kinds. That's how I normally teach it. So your first booklet or the sheet, the first handout teaches you how to do that. But you don't need to know it now. So you only need to shift up and down. So it's much easier to do. Okay. Let's do one more example. Here we go. I'm going to leave this one for you to try and then I'll write the solution. So this one is similar to what we just did. Let's flip over the page and do the one with the dilation now. Same idea, but with a dilation. So that 2 will change the number of x-intercepts you're going to get. Okay, so here we go. Let's do it. Same thing again. I kept everything else the same, still from negative pi to pi. It's a sine graph. I did make one difference. There is a negative here. What is the amplitude? Let's do this again. Amplitude of this function. What is that? Let's go with Molly. What's the amplitude? 2. So we say 2. So we can picture in our head already max 2, minimum negative 2. Great. We can see that it's a negative. So negative means instead of it being sine going up, down, back up, then it must be down, back up, down. That's what a negative graph looks like. Okay? We know it's sine graph, so I've drawn a sine graph. It's negative. What's minus root 2 mean? Down by root 2. So this is not as nice as before, but essentially I'm shifting my graph down by root 2. So that means my maximum now should be 2 minus root 2. And then the next minimum point is negative 2 minus root 2. Okay, so if I shift the graph down, this is what it should look like. Sorry, down by root 2. There we go. Something like that. So I'm helping you to visualize what's happening there. We went from 0 down, so this means the y-intercept, even without calculating it, we should already know it's 0, negative root 2. Okay, because you shifted the graph down. What's the period though? So how long did it take to make this one cycle? What's the period equal to? Can I please have Lockie?
Pi.
It equals pi. Very good. 2 pi on n. And n is currently 2. N is equal to 2. So it's pi. So that implies the very end point at the moment, that's pi. And the coordinate, since we shifted down by root 2, negative root 2, that means it's pi. Negative root 2, I already know that endpoint. The problem is there's a dilation. This here, n, changes. It's a dilation of factor 1 on 2 from the y-axis. What that means is I actually compress the graph by a factor of half. It means that you make it smaller. So instead of 1, you get 2 of them in the one section. That's what it essentially means. Which means you're going to get 2 intercepts, or more than 2 intercepts. Okay? But we're going to prove it. Let's prove that it's not actually 2, because if you're not careful with the dilation, you think there's only 2 there. But let's prove it. Y-intercepts, let's calculate it. Y equals to negative 2 sine of 2 times 0 minus root 2. So let's work it out. What's sine of 2 times 0? That's the same thing as saying sine of 0. And Umafi, you said before, sine of 0 is 0. So 0 times negative 2 becomes 0. We've proven it. Y-intercept is definitely 0, negative root 2, which I've already done. Okay? X-intercept is the only part that's tricky of this part here. Okay, this is the only part that you've been training to do. So let's do it. X-intercept. Let y go to 0. Get 0 equals to negative 2 sine of 2x minus root 2. Here we go. Let's go back to what the technique was again. What do you get rid of first? Plus root 2. Very good. Add root 2 on both sides. Actually, I'll do it in green. Add root 2. Add root 2. Negative root 2 plus root 2 cancels out. you end up with root 2 is equal to negative 2 sine of 2x. Divide both sides by negative 2. You now get root 2 over negative 2 equals to sine of 2x. Getting rid of sine, you do sine inverse on both sides. So you get now 2x will equal to the sine inverse of root 2 on 2, negative. This is where you have to think about your exact values in unit circles now. What was it again? Let's ask ourselves. Sine represents y values. When are the y values? Because the y value is going to be a negative root 2 and 2, so it's going to be negative. Which quadrants is sine going to be negative? 3 and 4 again. So very similar to before. It's quadrant 3, quadrant 4. Now you need to work out a base angle. Sine of what angle will give you root 2 on 2? If you didn't know, root 2 on 2 is the same thing as 1 on root 2. Okay, because root 2 on 2 is the same thing as 1 on root 2 because rationalized in denominator. That's how you get root 2 on 2. Okay, so which finger will give you 1 on root 2 again? Or root 2 on 2? Which one was it again? Sine of what angle? 30. 0.4. Very good. That's your middle. Okay, because if you did the 30 degrees, you get root of 1 on 2, which ends up being half. So it looks similar to 1 on root 2, but it's different. Whereas the other one, if you drop the middle finger down, that's root 2 on 2. Okay, because we always square root the number of fingers. So root 2 on 2 is this one. Okay. I write 1 on root 2 because if you memorize the table, they usually write 1 on root 2. But if you do it my hand method, then you'll get the root 2 on 2. All right, team. So we know it's pi on 4. Pi on 4 is 45 degrees. So here we go. This is now pi on 4 this way and pi on 4 this way. The domain was starting at negative pi. And you're going all the way to 0 and then back to pi again. All right, here we go. What are my 2 easy possible solutions so far? Yes, you're right. From negative pi, you rotate clockwise to get to pi. As you rotate, it's negative pi plus pi and 4. So we've got so far 2x can equal to negative pi plus pi and 4. That's one answer. So rotating at negative pi plus pi and 4. That's how I get my answer. What's the next one? How do you write the next one? If I rotate to get here 0, but I'm short of 0. So you're right? 0. Beautiful. 0 minus pi and 4. 0 minus pi and 4. So let's simplify that. 2x is equal to, shortcut is 4 times negative pi and then plus pi. Negative 3 pi and 4. And negative pi and 4. Notice that too? We're trying, that's the dilation. So now you're going to divide everything by 2. Remember what I said yesterday? When you divide by 2, for those who struggle with fractions, what do? Good, times the bottom. So that should give you negative 3 pi on 8 and negative pi on 8. Okay, so you've got 2 answers there, right? And that's where a lot of students stop because it was a lot of hard work to get there. That's very confusing. But this is what I'm saying. You got to check. You got to check, especially when there's dilations. It's very likely it's not going to be 2 intercepts. So let's check again. We said domain was negative pi to pi. Currently, you have, where is it again? Negative 3 pi on 8 and negative pi on 8. So you got negative 3 pi on 8 and you've got pi, negative pi on 8. You want to know if you rotated in the positive direction, if you rotate another revolution, are the solutions still in the circle? Or if you rotated backwards, so going clockwise in the other direction, will you get another 2 solutions that is in the domain? So how do you test it? Each revolution is a period. So you either add the period or you subtract the period. Now what's the period again? Pi. But since it's out of 8, it's easier if you just change that pi out of 8s. So that pi was 8 pi on 8. So you're really just saying, let's add 8 and subtract 8 to both of them, just to see what two sets of solutions you're going to get. So let's do it. Let's add. If I add pi, the period, so the period, if I add the period, which is 8 pi on 8, let's add 8 to both the solutions. If I do that, what's negative 3 plus 8? 5. So you have 5 pi on 8, or if you add another 8, so you go in that direction, adding another 8 gives you 7 pi. Do those fit in the domain? Is it more than pi or less than pi? Less than pi. This one's less than pi. That's also less than pi. So this fits. Here's another two solutions that you would have got had you gone one more revolution to the right. But then what if you went revolution to the left? Right? So you're going clockwise now. So if you go to the left, you're now minusing 8 pi on 8, which is minusing 8. So let's work it out. Minus 8. Negative 3 minus 8 gives you negative 11. And then this one is minus 1 minus 8 gives you minus 9 pi on 8. So you're just minusing, because you kept the denominators the same, you just minus the numerator, so minus 8. Now you ask yourself, is negative 9 pi on 8 and negative 11 pi on 8 still within the domain? Is it still part of the domain or no? No. Because negative pi means 8 over 8. So you've gone too far. Okay, so these two, you can't include. So my answer, when we asked what are the x-intercepts, you found the first two, because you only need two. In the unit circle, there was only two parts. For every revolution, there was only two solutions that you can get. So this is our first solution. We got the first two, and then from those first two, you're just adding on revolutions to find the next pair, and the next pair. Yeah? Whereas tan, you'll find later on, tan only has one solution for every revolution that you make. But that's for another time. So hopefully that makes sense of what you're doing there, why you add the period and why you subtract the period. It just saves you time, rather than drawing the unit circle and figuring out what you have to do. Yeah, so just add it on and subtract. So put it all together. Here we go, let's sketch. Whoa, what's going on? It's lagging. Uh-oh. What's happened to my screen? Too much maths. Can't handle it. It's not responding. Oh, it's back. Kind of. All right, here we go. Let's sketch the graph now. You had negative pi to pi, negative pi to pi. We know maximum was negative 2, so 2 minus root 2. You know that you've gone down the middle, which is negative root 2, and that's where the y-intercept is as well. And then you also had negative 2 minus root 2. Okay, so you got the amplitudes all there written. We know that one period was pi. Okay, so to make one period, it was pi. So that means when you solve for it, sine graph usually goes up, middle, then back down. True? I'm going to draw the midline so that makes it easier for you to see. And that's your max, that's your min. True? Usually it's like this. Max, middle, min. Yeah? But what was wrong? Why is that wrong already? It's reflective. Remember there was that negative? So in fact, it should be the reverse. It should be the other way around. It should go down, minimum, middle, max, comes back. Because we said one period was pi, and then conveniently they gave you a domain, or I gave you a domain of pi already. So it works out that that endpoint you don't even have to calculate. You already know the endpoint is at pi, it's negative root 2. But that's for the right side. If you go towards the left, doing the same cycle again, so this one goes up, max, mid, minimum, and back. That should be a distance of pi, because he told me the period was pi. Right? And this is why I'm saying that when you shift the graph left and right, it makes it harder, because it's easier to work out every quarter that you know roughly. So it's easier if you just do a vertical translation. So you keep the shape, it just moves up and down. Yeah? Sometimes the textbooks will change so that the domain doesn't work out nicely as one period. Sometimes it cuts off. That's why you have to work out endpoints. In our case, we don't have to, because it's just shifted down. And it fits one perfect cycle. Yeah? And the x-intercepts, you guys worked out the x-intercepts were, sorry, let me just draw that bit again because it looks a bit funky. Here we go. X-intercepts were at, what was it again? Negative 3 pi on 8, 5 pi on 7, 5 pi on 8, 7 pi on 8, so just slightly less than pi. The other one was negative 3 pi on 8, and your last one was negative 5 pi on 8. And that's how you would sketch these ones. So at the maximum level for your year, so in 2025, that's as far as you get. Okay? If you were asked to do horizontals, then I would have taught you the quarter periods, but this is how you would do it for the verticals. Okay? So verticals somewhat easier because you just shift it up and down, and that will tell you the y-intercept as you shift up and down. So that means your periods is a bit easier to figure out as well. Okay? So 3 things that you need: negative pi, negative root 2. 3 things. 1, 2, 3. Y-intercept, endpoints, x-intercept. If you get those, then your shape shouldn't be wrong. You should be able to get the correct shape. And hence, those are your 3 marks. Normally, your 3 marks are shape, x-intercept, or y-intercept in both. So you need to get both. And that's how you get your 3 marks. Okay? How does that feel so far? Was that better than yesterday? Was that give you a better direction what to do? So that summarizes G and a bit of revision of what I talked about yesterday. Amplitude period and the shape of the graph. Okay, so that ties it together. So 14I, look at the OneNote. There's only selected questions to do. Don't do the ones with horizontal. You do that next year. Next year, I'm pretty sure your teachers will teach you another method to sketch it much easier. It still takes a while. So on average, most students for the first time do take 20 to 30 minutes to do one graph. Okay? Yeah.
With the x-intercepts,
yep.
we started with negative 3 pi, negative 5 pi.
Yep.
Are those the intercepts?
Those are the intercepts that are within the domain, which is over here. So negative 3 pi and 8, and then negative 5 pi and 8. But you see, what I did was I then said, well, this point gets repeated. Notice the shape. It gets repeated again. So that's through one revolution. So this is the first revolution we got. Then what I did was I said, well, just in case there's potentially more intercepts, I said, let's add a period. From here to here, that's just doing another cycle to get back.
Isn't the negative 5 pi meant to be negative 3? The negative 3 meant to be negative 5?
No, because when you go negative, it gets more larger in values. So negative 5 on 8 is more negative than, it's like saying negative 2 is more than negative 1. So it's more left in that direction. So negative 5 on 8 is closer to negative pi than negative 3 on 8. Does that make sense? Yeah.
Did you say negative 5 on 8 was a solution?
Did I? What did I write? Oh, why did I write negative 5? Oh, my bad. Oh, is that what you're trying to say? Oh, sorry. It was negative pi on 8 and negative 3. I misread it. Sorry, my bad. Yes, you're right. That should be negative pi, and the other one's negative 3. My bad. Yes, you are right. I must have confused it when I read this bit. Yeah, so negative 3, we take that one. So it should be this one, then that one, and then 5, 7. Thank you. Very good. But that's it for today's lesson. I'm going to stop the video.